Question number 2. Now in this question we will look at another question which is usually asked in the interview process. So how to calculate power of number using recursion. So as always, firstly we need to think about our first step. So what is the first step? So the first step is to find the recursive case. So the question asks how to calculate the power of numbers. So from math we know that nth power of any given number can be expressed as like this. So x multiplied with x multiplied with x n times. So for example, 2 to the power of 4 means that we need to multiply 2 with itself 4 times. So we need to find the recursive case from here. So from math, we know that when you multiply two variables or numbers that have the same base, you simply add the components. So we can express the equation like this. So x to the power of a multiplied with x to the power of b can be written like this. So this is a rule from math. So based on this rule, for example, x to the power of 3 multiplied with the x to the power of 4 will be x to the power of 3 plus 4. So based on this equation, we can write our recursive case like this. So x to the power of n equals to x to the power of 1 multiplied with x to the power of n minus 1. So if we sum up 1 with n minus 1, so it's going to become n. So we can write our recursive case like this. So let's implement this recursive case in practice using Java. So I will declare our method over here. So method will be public int, which is going to return integer power. So it will take two parameters. The first parameter is base and the second parameter will be exponential. So both of them will be integer. Then according to our base condition, we will return base multiply with, we are calling this method recursively, so power with the base and exponential minus 1. So this is our base condition. Now let's run this method to see how this is performing. So for here I have created an instance of main class. So I will create another variable which takes result from this method and we will print out this result to the console. So here I want to try to calculate the 2 to the power of 2. So if I run our code, so you see that again our method calls itself infinitely. So in this case, how can we prevent this? So here we need base condition to prevent this case. Now here also I want you to pause the video and try to think about base condition of this method over here. So the reason why I'm doing this, to encourage you to engage in the interview question. So by engaging you will understand it very well compared to just by listening. So pause the video and think about it. So, okay, let's see how can we prevent this infinite loop. So here again, we have step 2 for this. So in which we need to find out base condition. So if we think about powers of any given number, we can easily remember that any given number to the power of 0 is 1 and any given number to the power of 1 is itself. So, which means that we can use as a base condition n equals to 0 or n equals to 1 because n to the power of 0 will be n and n to the power of 1 will be n. So we can write this condition as our base condition. So here in our method, I will write base condition over here. So if exponential equals 0 or exponential equal 1, then in this case, we will write return itself. So itself is base like this. Now if I one more time run our method for these values over here, 2 to the power of 2, we will see that infinite loop is prevented. Now you see that it returns 4, so this means that infinite loop is prevented. So we have base condition. Now we know that when we are writing recursive function, we have to complete 3 steps. So this means that we have not finished yet. So as you know, we have third step. So what is the third step? It is unintentional case, the constraint. So with this case, we can find out that what is unconditional case and what might miss in our method. So here the unconditional case might be like this. So if you calculate 2 to the power of 1.2 or 2 to the power of minus 1, what will be the result of these values for our method? So let's run our method to see how this is working. So here, instead of 2 to the power of 2, I will call, for example, 2 to the power of minus 2 and run our method. Now you see that it's calling itself infinitely. So here we have infinite loop, where the exponential is minus. Now, if we run our method, for example, 1.2, which we are putting floating number over here, so you'll see that Java raises an error. So in this case, we cannot call it with the parameter of floating because here we have declared our method as an integer. So this means that we need to write only unintentional case for minus numbers. So here I will write an intentional case for negative exponential. So if exponential is less than 0, then in this case you can return whatever you want. So in my case I will put return -1. So when it is -1, we know that it is minus, so we are not calculating for minus values. Of course it's possible to calculate it by writing different method, but in our lecture we are calculating it only for positive integer numbers. So that's why I'll put over here, if exponential is less than 0, we are returning -1. So now if we run our code one more time, for example, exponential as a -2, so you will see that our method returns -1. So here it returns -1, so it's not calling itself infinitely. So we have prevented this case also. So with these 3 steps over here, we are able to write a method to calculate power of numbers using recursion. So this is all for this lecture. So in this lecture, we have created a method using recursion for calculating power of number. Now in the next lecture, we will look at next interview question. So see you in the next lecture.